In the next several sessions here, we're going to be looking at exponents and their different uses of exponents, as well as some of their different properties. In this session, though, session 50, we're going to be looking at, in particular, exponents and their relationship with scientific notation. Before we go ahead and describe or define what scientific notation is, let's just take a quick review of some numbers, particularly base 10 here, raised to a particular exponent. 10 to the first power is equal to 10. 10 to the second power means 10 times 10. Well, what is 10 times 10? It's 100. 10 to the third power means 10 times 10 times 10, which is 1,000. 10 to the fourth is 10 times 10 times 10 times 10, which is equal to 10,000. 10 to the fifth, 10 times 10 times 10 times 10 times 10, which is 100,000. And lastly, 10 to the sixth would be 10 times 10 times 10 times 10 times 10 times 10, which gives us 1,000,000. And then exponents go on indefinitely. We can have 10 to the 7th, 10 to the 8th, 10 to the 95th, and so on. But exponents become very important as we use scientific notation. Exponents can help us represent numbers that are very large. Let's take a quick look here at this example. This particular problem says 3 times 10 to the second power. Well, once again, what is 10 to the second power? Well, 10 to the second power means 10 times 10. 10 times 10 is 100. 3 times 10 squared is 300, because 10 squared is the same thing as 100. What about 4 times 10 to the fourth? Well, what is 10 to the fourth? Well, 10 to the fourth is 10,000. What would 4 times 10,000 be? It would be 40,000. So here are a couple situations where we have a particular number less than 10 being multiplied by some power of 10. And a power of 10 meaning that the base of 10 has been raised to a particular exponent. Scientific notation makes use of exponents, and particularly exponents that are used with a base of 10. Scientific notation takes on the format of some number A being multiplied by 10 that's being raised to some power of B. A couple of conditions are that, first of all, that the letter A, whatever that constant is for A, has to be at least as big as 1, that is greater than or equal to 1, but it has to be less than 10. And then for B, B just has to be some integer. Well, let's go ahead and take a look briefly here at what I've started off with at the top left. We have 785 times 10 to the 0 power. Just as a quick review, any number to the 0 power is 1. 10 to the 0 power equals 1, 17 to the 0 power equals 1, and so on. Anything to the 0 power is 1. So what we have here, 785 times 1, because what is 10 to the 0? 10 to the 0 is 1. So we have 785 times 1. What is 785 times 1? It's 785. Let's take a look at our second one. Our second one here says we have 78.5 times 10. Well, how did we get to there? Well, let's come back here to our original problem. We had 785 times 10 to the 0. And even though we didn't write it, the decimal point always comes immediately to the right of our ones, or our units place. And the 5 in this number here is in our units, or our ones place. So the decimal number, or the decimal point, goes just to the right of the 5 digit. Now, what if we come here to the 5 digit and we move our decimal place over to the left 1 spot? Well, that's what we did down here. We took our decimal point that was right after the 5 and we moved it to the left 1. Well, in order for us to get the same answer of 785, because we moved our decimal point to the left 1, we have to increase our exponent by 1 on 10. Well, what was our exponent to begin with? It was 0. We moved the decimal place 1 to the left. 1 to the left. That then means we have to increase our exponent by 1 from 0 to 1. So what is 78.5 times 10 to the first? Well, 10 to the first is the same thing as 10. What is 78.5 times 10? It is also 785. Let's take a look at our next one. Here we have 7.85. Well, if we come back here to our original 785, in order for us to get it to between the 7 and the 8, we have to move the decimal place twice to the left. Well, if we move our decimal place 2 times to the left, we then have to increase our power of 10, our exponent of 10, by 2 as well in order to maintain the same value. So down here, we move the decimal place 2 times to the left. We then are going to multiply by 2 more than the 0, which means 10 to the second power. 10 to the second power is the same thing as 100. So what is 7.85 times 100? Well, it also is 785. So we have shown that there are at least 3 different ways that we can write the number 785. We could have written it as 785 times 10 to the 0. We could have written it as 78.5 times 10 to the first, or we could have written it as 7.85 times 10 to the second. However, only one of these 3 here are actually in scientific notation. And you remember verbally what I shared with you. What did A have to be between? A has to be at least as big as 1, but less than the number 10. Well, which one of these 3 over here have a number before it, before the 10 that's being multiplied, that has a number between that's greater than or equal than 1 but less than 10? Well, it's this third one right here. 785 is greater than 10, 78.5 is greater than 10, but 7.85 is less than 10 and greater than 1. So what we actually have here, 7.85 times 10 to the second, this is an example of scientific notation. Let's take this next number, 160,000. The question is, break that down into scientific notation. Well, where is the decimal point? Even though it's not visibly here, where does it always occur? If it's not written, it always occurs immediately after the ones place or the units place. So I'm going to go ahead and write that in here. The question is, in order to get this in the scientific notation, I'm going to have to get my decimal point all the way over here to the left where it's between the 1 and the 6. That would give me a 1.6, and 1.6 is greater than or equal to 1 and less than 10. So the question is, how many times do I have to move my decimal place to the left to get to that point, to that position? I move it once, twice, 3 times, 4 times, 5 times. In order to get my decimal place point over to there now, I had to move it 5 times. What am I now left with? Well, I'm left with 1.60000. And remember, if all you have after your decimal point are zeros at the end, you can drop them. So what I really have here is 1.6, and that has to be multiplied by 10 to a particular power. Well, what power is it? Well, I had to move my decimal place from my ones over 5 times. That means that I have to use 10 to the 5th. And remember from our previous screen, 10 to the 5th equals 100,000. So if we come back here, what is 1.6 times 100,000? 1.6 times 100,000 is 160,000. The reason why we can simply just move our decimal point to the left and then subsequently increase our exponent on a 10 is because our number system for place value is based on base 10. And since scientific notation is also based upon base 10, it helps us greatly in our calculation of how to create scientific notation. Lastly, here on this screen, we have the number 11,004. Question is, change that to scientific notation. Remember, once again, as I said earlier several sessions ago, anytime we reach questions like this and you want to pause the video, you can do that through your video player. Try the problem on your own and then restart your video player and see how the question or the problem was solved. 11,004, we need to write that as scientific notation. Well, once again, the decimal point is always after the ones place, the units. How many places to the left do I have to move it so that I get a number that's greater than or equal to 1 and less than 10? If I move it once, twice, 3 times, 4 times. If I move it 4 times, that gets me my decimal point right there. 1.1004 is greater than 1 and less than 10. So that satisfies that portion of the scientific notation. But I also now have to multiply it by a power of 10. Well, how many places to the right, or to the left, excuse me, did we have to move our decimal place? We had to move it 1, 2, 3, 4. That then means that we're going to be multiplying by 10 to that 4th power. This is 11,004 rewritten in scientific notation. 1.1004 times 10 to the 4th. And as a reminder, what is 10 to the 4th? 10 to the 4th is 10,000. 1.1004 times 10,000 is 11,004. As a review, scientific notation is very helpful in writing very large numbers. Scientific notation is also written in the following format. Some number a times 10 to the b power, where a is greater than or equal to 1, but less than 10, and where b itself is an integer. That'll finish session 50.